Algebra 1, Lesson 65, we are looking at our different equations and being able to write parallel or perpendicular lines, and also being able to see if two lines are parallel or perpendicular. So, first of all, parallel lines, these are lines that never intersect. And because of that, they have the same slope, but not the same y-intercept. We need both of these requirements, because if we have the same slope and the same y-intercept, that just means we have the same line, and it wouldn't be parallel to itself. So, we are looking for the same slope, for instance, a slope of 2 and a slope of 2, and with different y-intercepts, plus 7 and minus 5. These would be parallel to each other. Or a slope of negative 1/2 and negative 1/2, and a y-intercept of 3 or 4. That would work. So let's determine if these two equations are parallel. So first, we need to put both into slope-intercept form. So we're going to subtract 4x on each side and divide by 3. Which means we're going to need to compare negative 4/3 x plus 5, our first equation, and negative 4/3 x plus 2. Well, we have the same slope here, and we have different y-intercepts, which means, yes, they are parallel. Okay, how about if we are given we want a line that passes through negative 1, 1, and is parallel to the equation y equals 2x plus 1. Well, the first thing we need to know is what is the slope that we need in order for it to be parallel? Well, if it's parallel to this line, then it needs the same slope, so we need a slope of 2. And then we're going to substitute that into the point-slope formula. So, remember, point-slope our formula is y minus y1 equals m times x minus x1. So we plug them in. We say our y1 is 1, so we do y minus 1 is equal to the slope that we need, 2, times the quantity, x minus a negative 1. And we can combine that to just say this is x plus 1. So that when we distribute, so we can put this in slope-intercept form, we are going to say y minus 1 is equal to 2x plus 2, so y is equal to 2x plus 3. And yes, 2x plus 3 is parallel to 2x minus 1. How about perpendicular lines? Well, perpendicular lines intersect at a right angle. These lines are perpendicular if their slopes are negative reciprocals of each other. That means the y-intercept doesn't have anything to do with this, we just need to look at the slope. So our examples here are y equals 3x minus 7 and y equals negative 1/3 x plus 3. And we look at these and we say our slope of 3 and negative 1/3, those are negative reciprocals, because if we just had 3, the reciprocal would be 1/3, but for it to be perpendicular, it needs to be a negative reciprocal, or sometimes it's called opposite reciprocal. Another example, if we have negative 4 and 1/4, that means if we had negative 4, the reciprocal of it would be negative 1/4, but since we need it negative, a negative negative is a positive 1/4. So those are opposite reciprocals. We could have examples like 3/4 has a negative reciprocal of 4/3, or we could have, really you name it, anything that is the reciprocal and made negative. So we need to determine if the lines that would pass through these points would be perpendicular. So line 1 has points of negative 5, 4, and negative 3, 0. Line 2 has points of negative 2, negative 2, and negative 4, negative 3. So we find the slope of each line, which means we're going to use this formula that we've used before to find slope of y2 minus y1 over x2 minus x1. So we plug it in and we say y2 minus y1, so 0 minus 4, over x2 minus x1. And we can simplify. We say 0 minus 4 is negative 4 over, well, minusing a negative is adding the opposite, so we actually get a positive 2. So this is negative 2. What we're looking for is for the other slope to be hopefully a positive 1/2. And we see negative 3 minus a negative 2 is plus 2, so we get negative 1 over negative 4 plus 2, which is a negative 2. Well, A negative divided by a negative is a positive. And so yes, these are perpendicular. All right, so let's find a line that passes through -2, -3, and is perpendicular to the equation y equals -3x plus 1. Well, we need to find the slope of the perpendicular line. Well, the line that's given is a slope of -3, so its opposite of reciprocal would be 1/3. And then we use point slope formula. We plug them in and say y minus a -3 equals 1/3 times the quantity x minus a -2. And we can make it a y plus 3 and an x plus 2, and we can distribute to get y plus 3 equals 1/3 x plus 2/3. We subtract to get y equals 1/3 x minus 2 1/3, or we could say 7/3. All right, use the slopes of the line segments to show that LMN is a right triangle. Well, to be a right triangle, we need it to be perpendicular. So we're going to look, what is the slope of LM? Well, we make our slope triangle and see we are going down 4 and over 1. So the slope of this line, M, would be -4. And for MN, we make our slope triangle and see we're going to the right 4 and up 1. So our rise is 1, our run is 4. Are these negative reciprocals? Yes. -4 and 1/4 are negative reciprocals, so these are perpendicular, which makes LMN a right triangle. Let's just try a couple more examples. Determine if the equations create parallel lines. Well, we need to put them into slope-intercept form, so in the first one, I need to change it by subtracting 2x, and I get -5y is equal to -2x plus 10, and then I divide by a -5. And when I do that, I get y is equal to, well, we have a -2 divided by a -5, so that's a positive 2/5 x. And positive 10 divided by a -5 is a -2. So we would look and say, is 2/5 the same as -2/5? No, it is not. So these are not parallel. All right, let's find another line that is parallel to -3x plus 1, but goes through to -4. So I need a slope of -3, and I'm going to use that point. So we plug it in, and we say y minus the -4 is plus 4 is equal to -3 times x minus 2. And we can expand to get y plus 4 is equal to -3x plus 6, and subtract 4 from each side to get y is equal to -3x plus 2. And we say, is that parallel? Yes. Same slope, but different y-intercepts. That's what we were looking for. All right, some perpendicular lines. Let's find the slope of each of these to decide if they are negative reciprocals. So I'm going to be doing y2 minus y1 over x2 minus x1, which means I get a -4 over -1, so our slope is 4, a positive 4. On the other side, 3 minus 2 and 6 minus 2. So we get 1 over 4. So our slope is 1/4. Now these are reciprocals of each other, but they are not negative reciprocals. So these are not perpendicular. All right. Let's find the equation of the line that is perpendicular to y equals 1/6 x minus 3 and goes through 1, 2. Well, we're going to use our point y minus 2 equals something, some slope times x minus 1. And our slope needs to be the opposite reciprocal of 1/6, so we need -6. We expand to get y minus 2 is equal to -6x plus 6, and add 2 to each side to get y equals -6x plus 8. That would be perpendicular to y equals 1/6 x minus 3. And last example. Let's find if this is a right triangle. So we need to find what is the slope of AB, what's the slope of CB. So let's look at AB, but the first thing we need to realize is that the scale of this graph, we are going by 2's, which means when I find the rise and the run, I need to make sure that I am taking that into account. So I'm going to make this slope triangle from here to here. And the slope looks like I go, let me make that a good line. Let me erase some of those silly lines. All right, so when we do my rise, it looks I'm going 2, 4, 6, 7. So I go up 7, and to the left 1. Let's see. I'll go from A over. So we get 2, 4, 6, 8, 9. So we go over 9 to the left 9. So we have a slope of a rise of 7, a run of negative 9. Okay, let me erase a little bit. Let's see if we are going to get a opposite reciprocal for my other slope. Okay, so I'm going to do a slope triangle again. And when I'm going to go down, so I have 1, and then 3, 5, 7, 9. So I go down 9, and to the left 1, and then 3, 5, 7. So to the left 7. So I get a slope of negative 9 over negative 7, which means my slope is just 9 over 7. Meaning if I have 9 over 7 versus negative 7 over 9, these would be perpendicular. So yes, this is a right triangle. Well, I hope this is helpful for your homework and for studying.